Hi, I'm Paul. I'm going to present you the lab reports with the title Free Fall. Let's start with the introduction. Let me introduce the members of Group 1 which carry out the experiment. Amjad, Sairo, Hanna, Zaim, Pichin, and me, Paul. This is the basic theory of the experiment. When a body falls in the gravitational field of the Earth from a height to the ground, it experiences a constant acceleration as long as the falling distance is small and friction can be neglected. This motion is called free fall. If the body starts at the time t0 equals to 0 with the initial velocity v0 equals to 0, the distance is covered in the time is h equal to 1 over 2 gt squared. Thus, the free fall is an example of a uniformly accelerated motion. In the experiment, the free fall is an example of a uniformly accelerated motion. In the experiment, the free fall is investigated on an eraser which is released by hand due to its gravitational force F equals to m times g, m mass of an eraser. Its fall in downwards in a uniformly accelerated motion as soon as the eraser being released. In this moment, the stopwatch is started. Having covered the falling distance, the stopwatch was stopped when the eraser hits the ground and the falling time was measured. The measured result for various falling distance are entered in a path time diagrams as triples and the average time was calculated its value. As the eraser is at the beginning at the time measurement, equation 1 can be used to determine the acceleration of gravity. Accelerations of gravity g equals to 9.81 m over s squared. This is the objectives of the experiment. First, measure the falling times of the eraser. Second, determine the proportionality between the falling distance and the square of the falling time. Third, determine the acceleration of the gravity. Now is methodology. The apparatus we used is eraser, stopwatch, meter ruler, pencil, double-sided tape, and A4 sized papers. The procedure of the experiment is this. Let me show you this video for further explanation. Step 1. A4 paper is measured and labeled the height from the ground with 25 cm to 60 cm with 5 cm increment each by using meter ruler. Step 2. The labeled A4 size paper is sticked on a vertical wall by using double-sided tape. Step 3. The eraser is placed and released from the labels of 25 cm to 60 cm with 5 cm increment each of the A4 papers. Step 4. The time taken for the eraser to reach the ground is recorded. Step 5. Step 3 and Step 4 is repeated twice. This is the results of the experiment. As you can see, as the height increases, the time taken is increases. To visualize this data, we plotted a graph h vs t. The graph is increases exponentially. This is the table of the height and the square of the time taken. To visualize this data, we plotted the graph h vs square of the time taken. The graph is increases exponentially. This is the discussions of the experiment. First, plot the graph displacement h versus t. We have already plotted. Second, fill in the table with the square of the falling times and plot graph h versus t squared. We have already filled it and also plot the graph. Explain why we have to convert t into t squared. This is because h is directly proportional to t squared but not t. This is from an equations of the basic theory h equals to 1 over 2 gt squared. Third, from the graph, determine the magnitude of the gravity by manipulating the equation given in the theory section. Please show the alternative of equation until you got the equation of gravity. According to the formula, h equals to 1 over 2 gt squared, the gradient of the graph is equal to 1 over 2g. The gradient of the graph can be calculated with formula y2 minus y1 over x2 minus x1. These are the calculation done. The aftermath of it is 9.801 m over s squared. The alternative of equation until you got the equation of gravity is shown. The aftermath of it is g equals to 2h over t squared. 4. Comment about your graph and the value of the gravity that you get. Fill in the last column with the calculated value of g. We have already filled the column. The graph shows that h is directly proportional to t squared. It obeys basic theory. Fifth, discuss on how you can improve this experiment in order to get a better result. By recording the videos of experiment and calculate the time taken by using the frame rates of the video. This can eliminate the errors of human reaction time. Sixth, what are the precautions, actions that you take during this section? To avoid airflows in the experiment environment and release the eraser at the eye level to avoid parallax error. The last, the conclusion. From this experiment, we found that the falling distance is directly proportional to the square of the falling time. We also know that the acceleration of gravity is approximately equal to 9.804, which is slightly affected by the air resistance. Thank you very much.